Hello everyone, welcome back to the channel, and let's continue diving in with Python functions. We're going to learn a few more nuanced things about Python functions and some what I would call special functions in Python. So in order to do that, we're going to also bring back the timeMyFunc function we wrote in the last video comparing our Fibonacci sequence functions. And we'll do some less mathy things and do some more real life, what you might be using Python for, which is simple data cleaning or refining or file management or something like that. So let's say you had a list of names and your users mistyped their names and they had caps in the wrong places or something like that. And we simply wanted to correct their typing. So let's do that. Let's say get a function, we'll call it getProperCase. And that will take in a list of names. Now, once again, something that I've done a lot is I've called this names and I've called what I'm putting into the function names. Just know that you don't have to have it be the same name right here when you're defining the function. It's just saying this name is what we'll use in the function later, and this is what I'm going to be using. But usually you call them by the same name just so you know where things are going. But I guess I'll even switch it up just to show you that'll still work. Okay, so how would we get a list of proper names? Well, up to what we've learned so far, you would probably do something like this. You would create a temporary list or a new list, and then you would say for name in name list, using some good naming there, we would then say temp.append name dot, and what would I do? I believe it'd be proper case or something like that. But here's the issue with this right now is that right now I know I've got this name and I know this name is a string based on the data I'm passing in. But right now when I'm defining my function, I have no way to get that hint of saying, oh, I know what you probably want to do with a name. You probably want to upper, lower, split, something, any of those string methods we looked at before. So how can we get our text editor essentially to recognize that this is going to be a string and to pull up those methods? Well, that's what we learned about an even bigger idea called Python type hinting. So here's how you type hint. After you put the name of the variable you want, you put a colon and then you say what that variable is. And this is a list which contains strings inside of it. Now, just by typing that now that it knows name list is a list of strings, now when I click name dot, I now see the string method showing up because the text editor now knows, oh, when I iterate through this name list, I know every value is going to be a string, so I know that I can pull up all the string methods you might want. And the one I was looking for, let's see here, what was it? Not proper case, title case is what I want. So I want temp.append.title, and it says return version of the string where each word is title cased. Great. So now that I'm appending all those names correctly cased to my temporary list, I can then return my temporary list. All right, so what we learned is that you can essentially tell your text editor or other people using your Python code what you anticipate them plugging into your functions. Now, this isn't a strict requirement. You can get away with essentially putting something wrong inside of here, but it's more so a hint to you as to what you should be doing. And you can also give them a hint back that what they're going to get out of this is once again a list of strings. And now when I hover over this, you can see that it's saying I expect to get a name list, which is a list of strings, and I expect to get out, using that same arrow, a list of strings. And that even goes a step further. If I say my new list is equal to get proper case, I can even click on this and whoops, I guess I got to pass in a list of names. Let's pass in names. And I can now see that it already can anticipate that the new list is going to be a list of strings because it knows what this function is going to spit out because we type hinted it. So this is something I would encourage you to do with all of your programs. And not only that, but also comment. And we haven't talked about comments, but we will later when we do a more in-depth project. But this is one of the most powerful things you can do in your code because once again, what we said in one of the earliest videos was most errors are simple errors of I wasn't anticipating what I was plugging in or what I was getting out in terms of their data type. And this type hinting is your way in your own program of telling yourself, oh yeah, I'm going to get a list of strings out of this. All right, so great. Let's just see that it works, and then we'll essentially run that function, and we'll get our new list, and we'll see, whoops, what did I do? Names is not defined. Oh yeah, I got to run this cell up above. There we go. Now I've got everything correctly cased. Awesome. So we learned about type hinting, and we learned essentially how to make sure that when we type this name in the middle of my for loop, that I get the string methods I'm expecting so that I can write my code easier. So it's a really big help because, again, when we didn't have that list string in there, you would have had to have the string methods memorized and know that you wanted title case rather than looking through them. All right. I mean, I guess you still needed to know that you can title case, but it made, being able to tab and autocomplete a lot easier. Okay, but what's an even crazier or better way of writing this? Actually, what's an even better way of writing this? Well, let's now learn about Lambda functions, and we'll get back to default values later. So Lambda functions provide a way of, defining very simple functions without defining the actual function. And usually you use Lambda functions inside of what we call maps or filters. So let's show you what I mean by that, and let's dive right into a map. And if we just type map and put some parentheses, you'll see that map expects to make an iterator that computes a function using arguments from each of the iterables. Now, in other words, what we need to do is we need to pass in a function and some iterables, or in other words, a list or a tuple or something like that, and it will then create a map object, or in other words, it will find a way to apply that function we want to every item inside of our list. Now that's what we just did here. We wanted to apply the title function to every string inside so that we would get the proper casing. So we could do the same thing in one line of code rather than defining an entire function, and that happens via Lambda functions. So let's show you how it works with map, because it's likely we're going to be using Lambdas anyways. So let's just say my proper case names is equal to my map function. And the function I want, again, if all I'm trying to do is simply title case these names, I don't need to go about writing a big old function. What I can instead do is I can say lambda x, or I can say lambda name, and then I can say name dot title. Now notice this time I did need to know that I was doing title casing, and I can't actually do good type hinting inside of Lambda functions. There is a way, but it looks pretty nasty, so we'll skip it for now. But this is in essence my function. And now what I can do is I can apply that to my iterable, my list names. Now a map function will return a map object. And so if I want to get this into my final list, then I need to then turn this into a list afterwards. All right. And if I look at this now, it looks a little wacky. I get the same result as before, but I didn't need to define an entire function, and I was able to write it all inside of one line. So let's spend a little bit more time looking at what a Lambda function really does, and then we'll move on and talk about the filter, since we just talked about map. So Lambda functions, again, are a way of defining a function, here it is, without using the def keyword, and there are some criteria you need to know about. So when you have a Lambda function, you start it off by saying lambda, just like we start normal functions off by saying def, and then instead of giving that function a name, all right, that's what we're trying to avoid, just get me the function I need without making a whole proper name out of it. Instead of writing in the name, just write what you are going to be passing in. And I'm going to be passing in maybe individual values. Sometimes we use X here, but you might as well say name since we were working with it. So this name right here is essentially the same as like the name list inside of this function, only we're grabbing every single individual item, not the entire list at a time. So essentially we're saying I'm already digging inside of this list, I'm already digging inside of this iterable and grabbing one item at a time. What do I want to call that single item at a time? Well, it's a name in this case. And then what do I want to do with the name? Well, what I want to do with the name is I want to do name.title. And that's all there is to it. This is essentially the same as, and let's maybe even just write it out here. If we did this, def proper name, where we input a name and we return name.title, right? This takes 2 lines of code. We have to define an entire function and give it a name so that we can correctly title case our names, and it works for every single individual value. And so rather than typing this all out formally, since we're probably not going to be using this whole proper casing all the time, we really don't need to give it a function name. We can just create this lambda expression and do things, I guess you would say, a little bit less overtly and a little bit more covertly and still get the same result. So again, what the map function needs is the map function needs a function that will apply something to every individual value, and then what are the individual things you want to have it applied to? Where are they all stored? Well, in this names list. And so just to prove to you that it works the same way, let's do this. Let's call this proper case 2, and let's now do list map, and now let's type in proper name as that function, comma, names. And we get the same result here as well. So in other words, what I did want to make a point of saying is you can actually formally define a function and throw it into your map. It's just lambda functions kind of came about because usually when you're mapping something, it's maybe a simple function where you just want to square every number, or you just want to proper case all your names, or you want to remove extra white space from some strings. You probably don't need to define a whole function. You can probably get away with typing that function out in one line. Oh, and that is the one last thing to know about lambda functions, is that this function should be essentially a one-line function. And what I mean by that is after you write your def or whatever you would in your function, your inside needs to be one line of code, just return, and then this can have a little bit more stuff going on inside of it, but for the most part you're doing some sort of simple little operation that only takes one line, and that's how you make a lambda function. It's a one line function that doesn't need a proper name because you're just using it in one little place and then moving on. So that can be a super useful feature. And not only that, but let's now time these lambda functions and show you how much quicker this will be rather than doing this whole get proper case. So let's go ahead and do that. Now I'm going to have to do print. Actually, I don't think I'll have to print because it prints itself. So I can do time my func. And what I can do is I can put in the get proper case with the names. And then I can also do time my func again. And this time what I'll do is, let's see here. I guess I do have to kind of define this, but you'll see this still goes much faster. But let me we'll call this lambda names. Now I just need to write this in here just so that I can throw this into my time my func. There's probably a better way to do that, but this will work for now. Okay, anyways, let's see how these two compare. Whoops, lambda names is not defined. Got to define it. Now I can run it. Whoops. Lambda names is not defined. Whoops, takes in 0 positional arguments, but 1 was given. We got to put names in there. There we go. All right, cool, we fixed our error. All right, so hopefully you can see that using the lambda function and the map function went way quicker. We once again got that move that decimal over 5 places, whereas this one only had 2 leading zeros. This would have 4 leading zeros after you move the decimal. So not only is your lambda function smaller to write in terms of the amount of code, but it also runs way faster because once you are dealing with lambda functions and maps, you're digging deep into the original like Python code, and they've done a lot of work to make sure that that code runs fast and it runs clean. So when you're writing your own functions and writing your own for loops, you're likely going to be running slower than if you're using the built-in map and list functions. So there's something else to know. So in other words, lambda functions should be something you really start to learn and enjoy. And notice that, again, if you've got just some simple little procedure you need to do to every value inside of a list or a dictionary or something like that, then using a map and a lambda function can be a really quick and efficient way to do it, not only in the amount of typing, but also in the amount of execution time. So really powerful stuff going on there. Okay, Let's now go back a little bit and talk about default values before we talk about filter. So default values, I think we already actually talked about this in another video, but it's worth just saying one more time. And let's say that we wanted to, again, just let's do a simple one for the sake of moving on. Let's say we wanted to say hello and you wanted to pass in a name. Well, you can give a default name, which is maybe David or Bob or Steve or something like that. And then you can simply print hello and then using our f strings name. All right, so great. I've got this say hello function. And now if I simply write say hello and I don't pass anything in, right, notice my function didn't break. And before, when I typed in that lambda function without putting in names, remember I got that error that said we were expecting 0 positional arguments, but you gave 1, right? I didn't pass in any argument here, and this function clearly needs an argument name, and somehow it didn't break, and that's because if I didn't provide an individual value, it's going to automatically assign that to or give the default value of David. But if I instead provide a value, Bob, then now I get hello, Bob. Now, something else you can do in your code that you should do is notice you would call this technically a keyword argument. In other words, this argument has a specific name. We're saying the name is David. Now, what you can also do, and you might have seen it type in it before, is you can say, I want my name to equal Bob. And, do you need to write that in there? Not necessarily, but it can help make things a little bit more clear to yourself by just saying, well, what is Bob doing in this function? Is something going to happen to that string Bob, or what is this in relation to my function? Well, maybe if you just give it its actual name and say the name is Bob, then it makes a little more sense. Oh, we're going to say hello and we're providing a name, so we're probably just going to say hello name. Right? It's that little extra step of typing a little more that can make this code a lot more readable, even when it's something simple. But if you're building out something more complex, giving your variables you're passing in or parameters you're passing in keywords and then using those as you type them in can save you a lot of errors, just like type hinting what you're providing and what you're going to get out. Okay, we're almost there. Let's talk about the filter function and generators. So we're doing a lot in this video. So the filter function also is something you would usually use with lambdas, but instead of like mutating or changing each individual value from your iterable, you're going to check a true or false condition for that iterable. All right, so let's see here. What can I do? Let's do, let's see here. Let's say short names. And what we're going to do is we're going to once again have a list at the end because we're going to make a filter object. So notice that filter objects and map objects, if you don't put that list in at the end and you try to see what like short names is or what the other one was, proper case names is, it'll say that it's a map object or something like that. And you'll need to wrap that around a list or a tuple to actually then see the values show up in a list or a tuple like you might expect. So just be aware that map and filter will return map and filter objects that you can then transform into a list afterwards. Okay, so anyways, let's use the filter function and let's use lambdas inside of it again. So let's say for every name, I want to return essentially that the length of my name is less than 10 characters. All right, now I'm not sure any of them are. I think Mary Beth might be because that's 8 with 9 as the space. And then once again, we need to also, after we create our function that we're checking our filter against, we also need to provide names again. So now when I look at short names, let's see what happens. We got Bob Davis and Mary Beth. Now notice they're not correctly cased anymore because we're not doing that inside this function. But what we did do was we dropped off Martin Larry because Martin Larry is more than 10 characters, which would be false. So that is what the filter function does. It essentially says, I'm going to check this true or false condition, right? It's going to be a Boolean. That's the key for filters. You're making Booleans, true statements and false statements out of your items inside of your list or whatever iterable you're providing. And if it turns out to be true, then it will keep it and store it inside of this filter object and eventually inside your list. And if it's false, then it will throw it out and ignore it and pass over it, and it will no longer be in your list or filter object afterwards. So that can be a really cool way of kind of cleaning up data that you might not need. Maybe you don't want odd numbers, maybe you don't want even numbers, maybe you only want prime numbers. You could use filter to remove excess values that you don't need based on some sort of true or false condition. Awesome. Now, the last thing we have to talk about now, it's a special type of Python function, is a generator. And let's remind you of the generator you've been using a lot probably, and you just didn't know it. It's the range function. All right, so the range function, I mean, I guess we call it a function, but really we would kind of call it an iterator, an iterator or a generator. And it even says it returns an object that produces a sequence of integers by step and blah, 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 blah. You could read it a little bit more. But what I want to show you is that when you just type range 10, you don't actually get what you might think. You might think that when you type in range 10, that you get something like this. All right, or I guess, there's everything inside of range 10. But in other words, I think what you might have been thinking before is that, oh, when I type range 10, then what range 10 must be, and let's even compare it, it must be this list. And let's see if that is true. I'm actually curious. I've never done this before. I should do this before I make my videos. But is the range 10 object equal to this list? I don't know. And it actually says false. And why is it not equal to this list? Because range is not actually an entire list. It's an iterator, or you could even say a generator. Now, what is a generator and how do they work? Well, let's essentially recreate the range function ourselves and see how a generator works. A generator starts off just like a function. You write def, and then we could say my number stream. Like in other programming languages, sometimes they call this like range thing where you start from a number and continue on counting by a certain amount. They call it a int stream or something like that. So we'll say my number stream and we'll go to n, just like we provide an ending index in range. Again, you can do more than just that in range, but we'll talk simply for now. Now what we'll say is okay, we're going to start at 0, I equals 0. I usually stands for incrementer or something like that. So I equals 0, and then we're going to say while I is less than n, we want to yield, and that's the keyword I, and then we want to do I plus equals 1. Now this yield keyword is really, really special. Remember that if we actually wrote return I, this would actually just print out 0 because 0 is less than probably whatever value I'm going to pass in. I would write return I, and it would do one value, and it would break out of the while loop in the function entirely, because remember that when you see return, and actually, you know what, let's just do it. When you see return inside of a function, notice now that I kind of blacked out because it knows it's never going to get to it, because return breaks out of a function immediately. So let's make my number stream. And let's say I wanted my number stream 10. Well, I'm actually just going to get 0 and nothing else out of this, because return will break out of the function once you hit that keyword. But yield is different. And in fact, I can spell. Yield is something entirely different. Notice now when I write my number stream 10, you're going to get some unexpected behavior, and it's going to say you have a generator object. So rather than just make a generator object, I need to store that in a variable. So I'll say my stream. All right, so now I have my stream. And what can I do with my stream? What happens if I print my stream, right? You might think like you can print a list, I can print my stream. Well, no, we get this weird generator object. But what can I then do with a generator object? Well, you can wrap it inside of the next function. And let's even print next. And let's see what this does. So it prints out 0 because, in other words, when you write the word next, it's going to grab the first value you would have gotten out of this while loop, and it's going to give it to you, and then it's going to continue on until it hits that yield statement again, and it's going to be stopped, and it's going to be paused right there in that state where I is now 1, 1 is still less than 10, right? And so it's waiting to give me 1, but it won't do it until I run this cell again and ask for the next value. Now it gave me 1. So after it gives me the 1, after I call next, it will read the next line and it will increment to 2. 2 is still less than 10. So it's now going to wait to yield 2 until I call next again. So this number stream, or this generator here, is not actually producing an entire list from 0 to 9. It's actually just grabbing one value at a time and incrementing all the way through. And that is in essence what the range function does. So for I in range 10, print I, it's actually really behind the scenes calling the next function every time on this range function and giving you the values 0 through 9. And if you don't believe me, I can say for I in my stream, this will have some unintended behavior, but it'll be okay. Print I. Now also, there's two things we'll probably see here. Actually, no, just one. Notice that because my stream was already defined and I ran it for 0, 1, and 2, it's now continuing from the last value it knew, which was 3, and then it goes up to 9 and stops. So that's pretty cool that we can essentially grab values out of a stream or a generator by just sticking them inside of a for loop. Python has built in behind the scenes the ability to call the next function in this for loop statement when you have a generator object as opposed to a normal list. So that's pretty darn cool that that capability is in there right out of the box. Okay, so is there anything else to know about generators? Well, I guess the one last thing to know about generators is that what makes them such a tool to take advantage of is that, let's say you needed to go through some process 1,000,000 times, or you needed to add all the values from 1 to 1,000,000. Well, what you might maybe naively do is you might think that you need to you might think that you need to, I don't know why I'm naming it this verbose, but oh well. You might think you need to essentially say, I need a list of all the numbers from 1 to 1,000,000. And now you're eating up a lot of your computer's memory. I mean, not a lot in the grand scheme of things, but you're eating up a lot of your computer's memory by actually hard coding all those values in. Once you decide to wrap your range object or generator around a list, it actually will generate the list of all of those 1,000,000 numbers and store that list all at once. And now you're holding on to 1,000,000 values in a list, which can be pretty costly. Whereas when you have the range generator object or a number stream generator object, you actually only know one value at a time. It only knows that the current value of I, and it's waiting to yield that to you whenever you call the next function. It doesn't know how many values it's actually going to go through, almost in a sense. It just knows that it can keep calling yield until it breaks out of this condition and something goes wrong. So that's pretty impressive that you can do that with the generator object. You can essentially have a infinitely long list of values without storing it in your code, because you can always just grab the next value by calling next on your generator. So the next time you see the range function, when we say for I in range 10 or something, know that that range 10 is not actually a list. It is a generator object only going one value at a time. Okay, so with that being said, I think that's going to do it for that video. Generators are super powerful. Again, I would technically call them Python functions. It's just they're functions that will only give you one answer at a time until you call for the next one. I hope you learned a lot out of this function video. It's really been so fun going through the series with you so far. I hope to see you in the next one, where we tackle comprehensions, and classes are coming up soon. Not classes, but Python classes. So see you then.